Breathing in diesel exhaust fumes is like walking into a fire without a mask. Over time, those toxins lead to cancer. Protect yourself with MagnaGrip, the easiest, most reliable exhaust removal system that features a true 100% seal to eliminate diesel exhaust fumes. To get free grant assistance, visit magnagrip.com.
And I got to blame the Stop Believing Start Knowing thing on Kerber. It actually came from him. So we were at UL, and it was in 2013-ish, around there, and having a conversation. And I just asked him, like, hey, man, what's your goal to get, with the fire service, with all this research? Like, what is your goal? What are you seeing? He told me if I could just get firefighters to stop believing and start knowing. And that, like, just rang in my head. I was like, oh, man, this light bulb came on. And I was like, hey, can I use that? And then that's how the Facebook page started. And it just came from there. And we kind of became interpreters of the research to try to break it down to a firefighter level, because a lot of firefighters, they see the graphs and they just kind of get lost in all of that, right?
Welcome back to another episode of Fire Engineering's Tactical Impact. I'm your host, Jim Silvernail, and with me is my co-host, Chief Jason Hoevelman. Jason, it's good to have you back. I know you've been on the road. How are you, sir?
Doing good. It's good to be here. These webcasts come around pretty quick, and I was in Central Jackson County doing some garden department classes the last 3 days, and it's good to be home.
Outstanding. Today we're going to bring a pretty special show because there are two guests that we have on today. Have been friends of ours for a long time. Extremely great colleagues, great fire service advocates, and what I'd like to consider change agents in the fire service. But we're going to highlight, before we introduce them, we'd like to talk about what the show is going to be about, and it's going to really highlight their article in our Fire Engineering edition in July 2024 entitled, hit me up real quick, guys. It's a modern fire tack.
Modern firefighting tactics is residential structures, ventilation, coordination, and control.
The reason why I screwed that up because these gentlemen have had so many great articles, I had to remember which one we were doing, but that's the one we're doing.
Good recovery, Jim.
Thank you very much. I had it pulled up on my computer screen, Jason, and I pulled it down for an email. So you caught me. I am followable. So there it is. But without further ado, and I'm not going to botch this one up, but we got two great guys here today. We got PJ Norwood. PJ is retired from the East Haven, Connecticut Fire Department as the Deputy Chief. He now serves as the Director of the Connecticut Fire Academy. Welcome, PJ.
Thanks, Chief. Thanks for giving me the opportunity to chat with you and Jason and Sean about this article and talk a little about ventilation and coordination. We appreciate the invite.
Thank you, sir. And our good friend, Sean Gray, Captain down in Cobb County, Georgia. And I also want to mention that these gentlemen have wrote a book on the subject matter, The Evolving Fireground. I got that correct. So, like I said, these guys are very versed on the subject matter, and I really want to dive into this article because it's very relevant. As you know, this show is all about tactics, making a tactical impact, and I don't think you can talk about tactics anymore without talking about fire science and findings of fact. And I know these gentlemen are very big into factual, science-based fact. So let's get into this article before I screw up anything more here today. But the article we want to talk about is the modern firefighting tactics in residential structures. So, guys, give us a little background. Why did you write this article? And let's talk about some relevance.
PJ, you want that?
Sure, I'll jump in on it. Know me, I'm not afraid to talk and offer an opinion. So again, thanks for the invite. And what Sean and I have been trying to do over this past year and going forward into the end of 24, beginning of 25, is going back to our book and taking pieces or parts of our book out and creating articles on the different chapters to, one, enhance the education, to share that information, but also, two, to grab some information from the book and hopefully draw more readers back to the actual book instead of just the one topic. So this month, in July, Fire Engineering was gracious enough to publish our article on ventilation. And if you think about it, the vertical ventilation study, as we refer to, or the study of effectiveness of vertical ventilation in single-family homes, was published in 2013. That was quite a while ago. It seems like just yesterday we were arguing over all of the ventilation stuff that UL came out with. And I think this was one of the studies that when it hit, this was the big one, in my opinion, that's really impacted the fire service in a big way, because it opened up our eyes to a lot of things that we may have been doing that we could have probably done a little bit better. In my department where I came from, we were a small department, department of, 11 firefighters per shift. And we did vertical ventilation, and the department still does. However, we didn't do a great job at it because it wasn't possible for us to coordinate it with a two-man truck company or two firefighter truck company. So this article is written based on the chapter of the book, which comes from the study that was published in 2013 by UL.
So let's go back to 2013. What was going on back in the day when you guys decided, hey, this is important stuff. Let's get this information out there. Let's talk about what's going on in labs. How well was it received? Let's revisit this a little bit, Peach.
You both know that answer very well, and I'm not sure when Sean and I truly started, talking about this stuff, especially on social media with the Stop Believing, Start Knowing brand. And Sean could probably give some better information on time frames and dates with that. But as you know, it wasn't easy. And it's still not easy, but it's a lot better than what it was. There was a point where, there was a group of firefighters from an unnamed large city department near me in Connecticut that actually wanted to drive to Connecticut to physically beat me up because I was challenging their well tried and true tactics. And that's not just a metaphor. That was legit. They wanted to drive here from this big city and physically beat me up because I was disagreeing with their long tried and true tactics. So there was a period of time there, and it's happened very fast. The cultural change has really happened very, very quickly. And I think now there are still some that don't believe in the research. There's still some that don't believe in the studies or the interpretations of it. There's still some out there that are trying to put their own spin on it, which is not accurate or, like you said at the beginning, factual in line with the research. But listen, we're always going to have that. And but it's a lot better now than what it was. It was pretty contentious for quite a while there.
Yeah, we had people actually hate the Stop Believing, Start Knowing thing, said that it offended them. So and I got to blame the Stop Believing, Start Knowing thing on Kerber. It actually came from him. So we were at UL, and it was in 2013-ish around there, and having a conversation. And I just asked him, like, hey, man, what's your goal to get, with the fire service, with all this research? Like, what is your goal? What are you seeing? He told me if I could just get firefighters to stop believing and start knowing. And that just rang in my head. I was like, oh man, this light bulb came on, and I was like, hey, can I use that? And then that's how the Facebook page started, and it just came from there. And we kind of became interpreters of the research to try to break it down to a firefighter level, because a lot of firefighters, they see the graphs and they just kind of get lost in all of that, right? So if you're not that firefighter that's going to dig in and really pay attention to the details of the studies, that's kind of where PJ and I wanted to come in. So we created Stop Believing, Start Knowing, and then it just started running videos. And at the very beginning, it was very contentious. As the research was starting to come out, we were starting to challenge ideologies that from people in very large departments that have lots of experience, but they were really basing all of their decisions off of past experiences and not actually off of facts and research. So we were trying to combine that, right, with our own experience plus combined with the research and seeing if we could build a better product. And in the beginning, it was like this. And I think now we're definitely a lot molded together. Our Facebook page has very little contention on it now. So I feel like we've come a long way.
Yeah, that was all around the Governor's Island kind of set the tone for all these future tests. And even those being conducted in New York City didn't seem to curb some of the angst that people felt about the results that came from there. And so it's hard to believe it's been that those were that long ago already. And we have come a long way.
Yeah, it's exciting, right? I mean, all the research that we've done, and you guys have personally been involved in a ton of it. So, but yeah, it's great. I think it just keeps going. I mean, look at everything that's going on now with. I think emerging technologies is probably the next thing on the forefront. They're so involved with all of the batteries, and anytime there's a big battery fire, the first people that get called is UL, right? And is the experts there at FSRI, and even the Maui wildfires. A lot of people don't know about that, but UL was very involved in that and helped investigate the Maui wildfires. And so it just shows like how much buy-in that, we started with this little small group of people that nobody knew the hell who Steve Kerber and Dan Mazurkowski were. And now the governor of Maui is calling them and saying, hey, we need your guys' assistance.
Yeah, now you can't get on a panel. There's so many people that apply, you can't even get on a panel now, which is a good thing. There's a lot of interest. And before Jim takes you into the article, you two have been on the forefront of a lot of the research with the committees and all those things. Where do you think, what's the biggest obstacle do you think there is as it relates to the research for the street level firefighter? What are we getting wrong, and where do we need to pay more attention?
And I don't know about wrong. I think it's just one of those things where you really kind of have to challenge your own narrative, right? Challenge your own experiences. And that's where the ventilation piece kind of comes in, is that, I believe me, just even sitting on the advisory board, we've had long conversations with guys like David Rhodes and Mike Galliano, and they're legends in the fire service. And they're like, hey, you can't take away 20 years of experience on a ladder truck in a big city and tell me that that's wrong, because what we see with our eyes isn't necessarily exactly what the research is telling us, right? So I've seen it myself, right? Vertical ventilation can be very beneficial, especially when you're interior and you see that smoke lift come off and it gives you better visibility, and water's going on the fire and everything just kind of happens. You're like, hey, that was great. We, extinguished the fire very quickly and smoke lifted right out, and it just makes sense to us, right? But putting those two and two together, that if it's, I always joke and say B shift, if it's a B shift engine company that's on, right? And they kind of, the hose is kinked and they're not getting water on the fire, and the truck got ahead of the engine, and things can get worse. And it's really, that's what the research was saying, was like, if we put ventilation ahead of suppression, that is the challenge, and ventilation was getting ahead of suppression a lot of times. And so we were starting to cause more damage, make things worse, causing flashovers. People were getting burned and injured, and we had all of these examples, and people wanted to know why. And it was like, well, because there was ventilation before suppression. So, in the end, now you see a big challenge, and you talking about garden apartments, right, Jason? I mean, that's the whole thing that we talk about in that curriculum, is suppression before ventilation. And that's really the key, is we have to remember the types of ventilation that we're using. And I think that's one of the major distinctions when we talk about ventilation, is that it's really mechanical versus natural, right? Those are the two kind of categories. And vertical ventilation is the best natural ventilation that's out there, period. It is. We know that as part of the study. Vertical ventilation works when there's natural ventilation. But the problem is if we have mechanical devices in our hands, especially with a nozzle, and part of the coordinated attack study that came out showed that the most efficient way to get smoke out of a structure was with a nozzle on our hands and using hydraulic ventilation. It's very efficient, right? Pulls it right out of the compartment, right out the window. Works really, really well. And I will tell you, as being, as part of the people that were on the garden apartment research study and inside on those hand lines, that it was unbelievable how well that actually worked. I mean, it cleared out that breezeway. You've seen that video a bunch of times. Watch that breezeway completely clear with smoke. And that's all just with a simple fog nozzle. And so having that mechanical ventilation, positive pressure versus negative pressure ventilation, I think to me, there's some research there that we need to look at and see what's better as far as like pulling smoke out and out the window, or actually trying to pressurize an area and push it through. And that's where we need to focus next, I think, on ventilation.
And the other thing that goes against us is our training. We set our firefighters up for failure, in my opinion, for the fire grounds, because where are we training? We train in concrete buildings or metal buildings in training. And when we vent those buildings in training, what happens? Everything gets better. It doesn't matter when you open those windows or when you open up those doors or you create that vertical ventilation, everything gets better. Well, on the fire grounds, we know that ventilation doesn't make it better. Water makes it better. So we set our recruits up for failure because we put them in a flashover simulator. We have them believing that they can survive a flashover when they're actually really only seeing flame over. They're not seeing a true flashover. Then we put them in concrete or metal buildings, and when we vent, everything gets better. We go to the fire ground, and it's very different, as we all know on this call. So it's a combination of, our training education from day one kind of sets this mindset in each one of us. And then you have a group of scientists, guys in white jackets with little propellers above their head telling us that something different. So 1 + 1 doesn't equal 2. So it's very hard to change thought processes and change a culture when we are taught one way and we experience something that's very different.
And I think along lines with the ventilation piece too, when we start to talk about tactical priorities on a fire ground, the departments that are out there that are still venting before searching, that's a problem, right? Like we really want to, and that's something where I've been really trying to challenge the narrative, especially if I go and I'm speaking on the West Coast, because the West Coast of the country is still very truck heavy, vertical vent to the roof, every single fire, first 2 trucks to the roof, right? And so once I go out there and start talking about VES and the search study and how successful you can be and, start talking to those truckies, it's like, hey, who in here likes to go to the roof? And everybody raises their hand, right? And they're like, yeah, it's awesome, right? It's bitching. We go up there, we cut a hole, smoke and fire comes out. Everybody's filming us while we're up there on top of the roof. I mean, it's one of the coolest jobs out there, right? But then I'd say, well, what's really even cooler is when you put a ladder up to a window, crush the glass, go inside, go in there, pull a victim, bring them out. And then you're going to the award ceremony the next year, right? Because you got a civilian rescue. That's a lot cooler than cutting a hole in a roof. And it kind of starts to change some mindsets and just really trying to change some narratives that search needs to be the priority before ventilation. And when you can make that stuff happen all at once, it's amazing, right? You have that kind of symbiotic relationship on the fire ground. But getting people to think differently about tactical priorities, because everybody wants to cut a hole in a roof because it's really cool to do. But it's way cooler to pull somebody out.
I can't agree with you more, Sean. Jason and I just taught a 12-hour workshop in our state. And when we got to truck company operations, we asked people, what do you think truck company operations were? What do you think people said? Getting on a roof and cutting a hole. What percentage of truck company operations really is that? But I think those make very good points. But let's get into this article a little bit, and let's start off with misconceptions. So, I think it's very important to talk about back in the day when we started. And I know that your article started off with a little category called historical perspective. And I think that's important to get into. But it's also important to talk about some of the misconceptions that you guys are setting straight. One of the biggest misconceptions was you're going to put truckies out of business because, everything was bastardized in the fact of vertical ventilation and ventilation, which just wasn't so. So let's get into who wants to talk about the historical perspective behind this article.
Go for it, PJ.
So I'm just going to give you my firsthand experience. So I started the fire service in 1988, got hired at the career department in 95. And when we went to fires in my department, if we left a private dwelling fire and there was glass in the window, the shift commander was all over us because we didn't vent the building enough. All right, we were taught you have a window, you take a window. You get a company to the roof, you cut a hole. There's nothing about coordination. It was you go buy a window, I don't care when it is, you take the window, right? That's how we were taught, right? So that was ingrained in my soul coming up as a firefighter, and I'm not the only one. And that still was taught for many, many years, well into the 90s, and in some places probably into the 2000s, so when we were taught that way, and then the vertical ventilation study comes out and published in 2013, and we started realizing the negative effects of ventilation, well, everything that I saw on the fire ground with ventilation was positive. I didn't realize all the buildings we were burning down and the 3-story woods that are now 2-story woods because we burned the whole 3rd floor off was because that we would just vent the crap out of buildings, right? Because we would vent, but we didn't have enough firefighters to really put the fire out and search at the same time. So we were burning buildings down and really didn't realize why until now. So I think the biggest misconception that in the historical perspective for me is that I was taught one way, and I operated plenty of fires that way. But we now know that there's an important piece that ventilation needs to occur in the fire ground, but the where and the when is very, very different. I'm not against vertical ventilation. I'm not against horizontal ventilation. I'm not a guy saying that you should not be up on a roof cutting a hole, because those are important pieces of our fire ground tasks. But we need to making sure that we have communication with the engine company and making sure that we have water on the fire, or that engine company is in place to get water on the fire. And I think Sean and I may have a little differing opinion on that. I think, and Sean, correct me if I'm wrong, but because Sean operates in a larger department, so he's water on fire and then ventilation. In my department, that's a lot smaller. There are times that we have the engine company in place, but they need some help, right? They need help making move in, because there's one firefighter, maybe two firefighters making that stretch. So they may need to get that lift, but it's a calculated, coordinated decision to vent prior to water application. The engine company's in place, they're ready to flow water, the line is charged, and they coordinate together. I think that's the key. And that's a big difference from the way that, I came up in the fire service.
Yeah, I think for us, like a lot of times for roof ventilation in my department is we may miss opportunities on a good home that we could do roof ventilation on. And it's really because we got water on the fire so quickly that the timing's just not there anymore. That lift isn't there. And it's like, hey, by the time you guys get ladders and the saw and everything else up there, the fire's out. Like, so that's really kind of where we have evolved, where our higher priority is on search, and ventilation is definitely next, right? So it's fire attack and search happening at the exact same time. We talk a lot about our search culture and searching opposite of our hose line rather than coming through the front door. We're going through a rear door. We're going through windows. We're flooding the building with people. We're flooding the building with water at the same time. And then ventilation comes right after that. And if we can, if it happens to be in one of our stations, like down our south side, like 7, 22, and 1, those guys are like right on top of each other. There's a heavy rescue down there and a truck company. They can get a lot of things done in the first 10 minutes on the fire ground. But that's not every territory. That doesn't happen in the territory that I work in. So my truck company, we're focusing on search. So it just depends, on where you are and exactly the first arriving equipment, like that picture that we have coming up here later in the thing we'll talk about, because that's an interesting story too.
Awesome. Let's get into some of your graphics here. Let's talk a little bit about this. You put this pre-vertical ventilation in here, and you talked a lot. What's it? The bidirectional flow. Hopefully people have had classes by now, if you're on a fire truck or on a truck or an engine or wherever, that you've heard these terms before. But let's hear them from the experts. Talk about the slide a little bit. One of you two, please.
Yeah, so I love these slides. These are from our fire dynamics boot camps, and we've been traveling the country for a little while now doing these boot camps. And so these are UL FSRI slides, and Dan and them put them together. But so let's just say this is your initial entry into the door, and when you have a bidirectional flow path at the front door, that should tell you that the fire is on the same level as you, right? Understanding what that neutral plane looks like at the front door, the fire is on the same level. So that's a win, because now I know exactly where the fire is. It's on the same level. We can get down low, do a hook and look there at the front door, look to see if we have any victims near us, and then enter in the hose line and be able to try to make the push into there, right? So that is just prior to making our cut and going to punch through. You have a bidirectional flow path. Now, in that bidirectional flow path, you should know when you open that front door, you're going to have smoke and fire moving towards you, right? It should not be surprising that if you keep that front door open, and again, it's B shift and they're not doing a very good job stretching the line, they left the front door open. When flames come out that front door, you shouldn't be surprised by that, because it's traveling from high pressure, like in this photo to the right there, to the door, low pressure. It's traveling from high pressure to low pressure. It's going to get worse the more air that you give it, no matter what. That's physics, right? So this is our pre-vertical vent, and the engine company, just as PJ said, they kind of maybe get hung up. Like in his department, they might get hung up. They can't see anything, so they need some assistance with ventilation. All right. So you want to go to your next one? Perfect. All right. So this is the home run right here, right? This is that moment that all of us with the experience of vertical ventilation have seen it, right? This is that piece of you can't talk Mike Galliano and David Rhodes that vertical ventilation doesn't work, because this is the part where they've seen it, right? They work for departments that have lots of staffing. They're on scene. Engine company does a good job. Truck company does a good job. Everything happens. This is the win, right? So we got cool air coming in behind us. This is why some of the big challenges historically that were where people, when they came out and you all said ventilation doesn't equal cooling, and we had a bunch of truckies going, that throwing the BS flag, right? It's like, no, that's not true. I felt it get cooler. I've been inside and I felt it get cooler. Well, it got cooler because the fire was pulling cool air through the front door, just like these arrows are indicating, and all the hot gases and smoke are no longer going over top of your head. You changed the flow path. You changed that bidirectional flow path to go out of a vertical vent opening and go up and out. So yeah, there isn't any smoke or fire coming out anymore, but over top of your head. So this is that temporary lift. Now, again, if it's B shift and things are going bad on the hose company stretch, they can't quite reach it, whatever is occurring, they have kinks in their line, and the truck has gotten ahead of the engine and they don't have water on the fire yet, things can get worse from this point on. So you have that temporary lift where you do get an increase in visibility, you get cooling coming in from behind you, and you have an improvement in the limits of the flow path, right? But the problem is if water doesn't get on the fire. This is where everything can go bad. And that's all UL is saying. Is like, yeah, you get a temporary lift. However, if water doesn't go on the fire, things are going to get worse. So next slide will show you that.
Now, Sean, while he's going to the next slide, that temporary period that you're talking about, FE&Y actually has that listed in their books. It is defined as a temporary improvement period between ventilation and water application, which I think clearly defines exactly what you're talking about.
Yeah, that was an update, right, that they just did after Governor's Island. I think that Chief Lieb and our friends Cirillo and Healy and stuff got some changes into place. Now, so this is that post-vertical vent without water on the fire. Now we have an increased amount of smoke over top of our heads. The fire has obviously gained in size, gained in temperatures. Things are getting worse, and it's because of that vertical ventilation opening. So what the research and what our article is talking about is like, you just need to realize that when you cut a hole in a roof, that doesn't necessarily mean that that's the answer, right? That doesn't mean that it's a win. Everything has to come together. It must be coordinated. We got to get water on the fire. The truck's got to make the hole. Everything has to happen at pretty close to the same time. And when you start thinking about what that timing looks like and what your department staffing looks like, there's not a lot of departments in the nation that can pull this off perfectly, like they're drawn out in this, So that's some of the pieces when in our classes we talk about when we pull these slides up is we challenge people and say, realistically think about how your fire grounds go and what is the arrival assignments, how much equipment is arriving, how many people are on that equipment, and then can you realistically pull this off? And most people just can't. And that's the reality. Most departments can't do it. So that's where some of the challenges come in.
Sean, that's a great point, and I always point that out in our area. It's not that vertical ventilation is wrong; it's just that we don't have the staffing or the resources really to support it. And this slide makes a ton of sense, Or it's the opposite, that we're in so quickly that we're venting before the hole is actually cut. I mean, there is a coordination effort that has to occur, and you have to have the right system to make that work.
Right.
And I think that's the misconception, because there's a lot of people you talk to today and they're like, why did UL and everybody come out and say that vertical ventilation was wrong? And that's contrary to what they're saying. And you've already pointed that out. It's not that at all. It's the coordination aspect.
Yeah. UL actually doesn't determine tactics. It's the same thing, where people kind of mix up the wording of blue card. Oh, blue card's doing tactics. No, they don't. It's an incident command system. It's a language, right? UL's the exact same way. So Kerber and all of them, they will tell you like, hey, what we do here at UL is we measure tactics. Like we put together the research, we take things, we measure it, we do all of the findings, and then we let the American Fire Service decide. They take the research results and do with it what you will, and then create your tactics based off of the research results. So they're just measuring the different tactics back together. They've never said one is better than the other. They're going to tell you, hey, here's the results. And, and you can take, like I gave an example, the coordinated attack study, where you can take that in the garden apartment piece, the best ventilation that we did on those experiments was by far the hydraulic ventilation. It's twice as fast as a fan. So that's where I was like, I think there's more research to be done on the negative versus positive thing, because it was mind blowing to really see how well that actually worked. I've never seen on a real fire ground work that well. And that could be nozzle operator error. Maybe we didn't have the right nozzle application. Maybe we weren't the right distance away from the window. I mean, there's a lot of factors that go into that, right? And that's a training issue that we can come up on and start to dial things in. So what we do now, like here in Cobb, that is part of our academy. Like they get an entire piece in our ventilation group talks about hydraulic ventilation with nozzles. They know exactly how many CFMs we're getting out of our nozzles, and they fill the building with smoke and show exactly how it works. And the same thing with our boot camps. That's what we tend to do is kind of drive home the message to show like how you can actually use that. And it doesn't have to be a fog nozzle, because then you get into the argument of the smooth bore versus fog, right? So you can do it with a smooth bore. You can do that 1/3 bail, right? Take off the tip, do 1/3 bail, and move the line and get just as much air with a smoothbore nozzle as you can with a fog. So I'm not saying that I'm smoothbore or fog. I actually, when people ask me, are you a smoothbore or a fog nozzle advocate? I'm a smoothbore advocate because firefighters can't screw that up. It's just open and close, right? So a fog you can screw up. You can drag it across the ground. It turns into a fog. You make it push down the hallway. And next thing you know, it's like, oh, sorry, let me put that back to straight stream. But yeah.
I think it's funny because you did make a good point. Is like, remember when I'm in about the same age group as you guys are coming through this. I think I went through the fire academy. I volunteered for a while, but actually went through the formal fire academy in 96, 97, which wasn't that long ago, but it was long enough to go to be off the old principles. Sure. But I remember that, we were trying to teach an aggressive truck culture, break every window that you see and take everything you can for the lift, right? But what was on the first week of rookie school? What's in there? And that's a fire tetrahedron, fire triangle, whatever version you're on. And what's on there? Oxygen. So as a young kid, you're thinking to yourself, well, if I vent, aren't I giving it oxygen? But nobody dared to change what we were doing. Sure. I mean, everybody probably thought it, but no one dared, hey, do not mess with what works, kid. Go stay with what we're doing. And it just took us how long to start, challenging that. And of course you're going to get, feedback, a little bit of pushback when you do that.
Sure.
Let's get into this one. So Sean sent me a picture of a fire that happened in Cobb County just a week ago?
Yeah.
Okay. And so we want to kind of put all these principles together and talk about timing a little bit.
Uh-oh, my tones may be going off here in just a second for a commercial building fire. So I'm going to tell you the story real quick. So this is our engine 16's first in. So it's engine 16 and squad 16 that are arriving first. Our heavy rescues, our squads have 5 people on it and 4 on the engine. So they arrive with 9. So they basically split the squad for search, fire attack, and vent at the exact same time. Now, you tell me when 9 people, what fire department shows up with 9 people on the exact same arriving apparatus. So we're able to do this. So it was perfectly coordinated fire attack, search, everything happened all at the exact same time. And so this was a great job done. But the reality, as I told PJ, well, the squad, guess what the squad doesn't have on it? The squad doesn't have a fan. So they needed a truck to show up with a fan in order to do regular ventilation. But hey, guys, I got to dip out. I got to go to commercial building fire. So love you, Mean. There's the photo. Hopefully, I hate to bail and run on you, but we're short.
No problem. Keep your computer open there, buddy.
All right, I will. Thanks, guys.
See you, Sean.
Unfortunately, Sean had to bail, but this is a great picture for all of us to look at. Jason, how would you guys attack it when you arrived?
We're very similar to what Sean described early on as it relates to, and St. Louis County is unique, and being in the north part of the county, we're kind of one of the older parts of the county, and so we're very close together. And so when I get a first alarm, it's like I get a lot of resources really, really fast, and so we don't do hardly any vertical ventilation. Not saying that we won't, but because we get big numbers really quick, we get water in the fire really quick. It's rare to see on our scenes what you see there that's coordinated with fire attack. Now, there are occasions that it does happen because the circumstances allow, but not very often. And then we do a lot of the horizontal ventilation because of that.
I looked at it when Sean sent this picture, looking at it on my iPhone, I just started zooming in, something that you really can't do here, looking at different pieces of this picture. And if looking at it on the screen right now, you can see it, but if you're directed to it, if you look at that bay window or the bow window, depending on what you call it, on the leftmost pane, right at the top, it's a little bit dark there. When I zoomed in on my phone, you could see the amount of soot and heat staining at that level. So, this is obviously a 1 second snapshot in time, but you can tell by some of the other fireground things that we can zoom into this picture and see that, they have the lift. This is not just an attic fire that, they had lift because there was soot and smoke and heat pushing out of those eaves down at that window level. And then if you look towards the right side of the picture, look at the exposure. You can see the vinyl siding that's significantly impacted on that exposure. So there was a heavy volume of fire there.
Great point. Absolutely great points. Let's switch gears a little bit. We lost Sean, but that's okay. We got PJ here. PJ, I'm more than confident that you can pull this off on your own. We're going to get into some of the findings of UL and really and these are the facts that we should be using. I mean, a lot of us wrote tactics books back in the day, and we didn't have these facts. So it was all based off on-the-job type experiences. Some of our experiences, as we know, we got a lift. But really, were you really achieving, what you wanted? Or were you getting the full picture? So let's get a full picture. Let's get some science-based facts and kind of talk about it a little bit. A little hard to see here, but if you zoomed in, you could see it on a full screen. But these are things that have been proven. So, PJ, you want to dive into them a little bit? Can you see them all right? Or
I could. And you know what a lot of this comes down to, guys, and I know you guys understand this, is that it's something that I did not, because I didn't pay much attention in science and in high school, is that we as the fire service, and we've all said it, is that every fire we go to is different. But in reality, the combustion process at every fire is exactly the same because it's physics. It's the building that it's in, and then the conditions that either support it or suppress it, based on if we're applying water or if it has enough oxygen or not. So when we start looking at fires, every fire in reality is the same. It's the building that's different. So you look at the key findings of UL, fire intensification with ventilation, straightforward physics, right? If we add more air, the fire's going to get bigger. The only thing that's going to impact that is water. So water for the wind. 2, coordination of ventilation, fire attack. We kind of hit on that already. This is the funny one. 3, fire attack, crew entrance ventilation. Now, when we were all taught and we continue to teach forcible entry, we always teach door control. Force the door, control the door, right? But what we missed, at least what was missed when I was taught, we weren't told why we were controlling the door. We were doing it, right? We just didn't really know why we were doing it. Somewhere that translation got lost. And I remember in the late 80s, my very first forcible entry class was by Captain Rex Morris, the captain of Rescue 1 at the time, long-term FDIC instructor, and he had a channel locks with like a 3-foot piece of dog chain welded to it. And he said, before you force the door, you clip this to the doorknobs. When you force that door, you can control it, right? He was teaching us door control back then to limit ventilation until we got water on the fire, but it was lost in the translation of why. And then this big one, this is number 4, external water application for self-vented fires. We can spend eight hours on exterior water application, and we can talk about all the, all the controversies with exterior water application. And I think what it just comes down to is water for the win, right? The water doesn't know where the fire doesn't know where the water comes from. The fire has no idea if it comes in the window, comes in the door, if it comes down the hallway. So water is going to win every single time, and depending on the situation. It's not for every fire by far, but there's a time and there's a place. And there's some places that use exterior water on a regular basis just because of their staffing. There's some places that will hardly ever use exterior water. There are some places that use it that the majority of their firefighters will deny they've actually used it, but we've seen videos of those big city departments utilizing exterior water. So it's an accepted practice that only has positive results if it's done properly, but it's not for every fire, and there's a right time and place. And then the last one I'll hit on your screen is VEIS. So we'll hit the first controversy with VEIS. You hear firefighters say, well, I don't say the I because I've always been doing it right. And, the sarcastic firefighter in me says, well, that's good. Well, why do you say the E then? Because you have to enter, right? So I think the I, as we all know, we've been taught how important, how critical it is, but it's super important that we communicate that to our upcoming firefighters to make sure that we're getting in, we're performing VEIS, we're controlling that door. And then the piece that we miss with that, in my opinion, is many of our departments promote and utilize the Close Before You Doze fire prevention education campaign, but some of those same departments are not proficient, practiced, and trained on VEIS. If you're going to tell your citizens to sleep with your bedroom doors closed because we're going to come get you, you have to be ready to go get them. So you have to be trained and prepared.
Pete, those are great points. Thanks for summing up the findings. I'm going to ask you a question. What do you think was harder to accept and is still being hard to accept? The actual coordination of the ventilation piece or the hitting it hard from the yard? And I'm sorry to use that terminology, but what do you think?
I don't care what you call it, right? I'm not one of those. Those things don't bother me. I definitely think exterior water is a harder issue for a percentage of the fire service. But again, it depends on where you go. Sean and I have been in places, we start talking about the great debate, we called it, in our class originally in our book. And we don't understand what the debate is. We use that all the time because we're showing up with just one firefighter. We put water in windows every single fire we go to because we don't have a choice. And we make a lot of saves for it. And then you come to larger departments or areas around, say my area, that it was not accepted practice. However, a blitz attack is an accepted practice that's been around since the 60s, originated in Chicago. So tell me what the difference is. If you're saying a blitz attack is okay with a a mounted deck gun or mounted monitor, but the same water application from 1 3/4 inch hand line is not okay, it doesn't make sense to me. So
got a cooler name, PJ.
Say again?
Got a cooler name.
Yeah, I get you, a cooler name, right? So those are some of the things when you really break it down. It's water. Doesn't matter where it comes from. Get water into the compartment as soon as possible, however you could achieve that. If that's in the front door, great. That's through the window, perfect. Just get water into the compartment.
It's that locate and confine, right? I mean, it's locate and confine. That's what you're doing, facilitating the search.
Wait a minute, PJ, but aren't you pushing fire onto possible trapped people who are in that building?
Yeah, if you're not well trained in your nozzle and you have a combination nozzle and you go to 30, 40 foot, degree, of course, you're going to move products of combustion and, heat and gases. Sure. But you know what? If you're applying that water properly and it's not just, willy-nilly, like Sean likes to say, perfect on cue as he rejoins us, right? If you're utilizing that water properly through the properly placed hose stream, no, it's not going to have a negative impact on the environment.
I think it's very important to show or to really talk about one of the key finding too is that water doesn't push the fire. It's the air entrained in the stream that pushes the fire, and that you have to be trained on how to do it. In our area, I think we got used to it. We were doing it for a while too, just because you get fires that extending outside and auto exposes. You're going to have a fire in an attic very quickly. And the time it took us to get around and inside the structure could be the difference between an attic fire or an upper floor fire or just a single story fire. And I think that, that we had already been thinking about that. And a lot of times, too, the last point I'm going to make before I want Sean to start talking about this stuff, he doesn't get out of this altogether, is that, a lot of times they'll say, oh, this is a great tactic for understaffed departments because if you can't get in quickly, this is the way to go. It's for everybody. I mean, it's not just for understaffed. And when we were teaching, the principles of modern fire attack, we wanted to stay away from lower staffed, that it's an advantage. It is, but it's for everybody.
100% is for everybody. And you know what? And I said it before, there are big city departments that 98% of the firefighters and officers will deny they use exterior water. and we could show you videos of those same departments doing the same thing with success. Doesn't matter where you are, what part of the country you're in, water wins when you can get it into the compartment.
Yeah, I mean, that's, something we preach here, where we started, I felt like we were getting too complicated in the discussions, exterior versus interior attack and transitional attack and all these words, right? So we just took away all of that. And we just told the kid with the nozzle, hey man, this is your nozzle. When you see fire, I want you to put water on the fire. I don't care where you're standing, put water on the fire. So if you have a charged hose line and you're waiting for your officer to finish at 360 and there's fire blowing out the window, we expect you to flow water in that window. And you've been taught how to do that properly, and so that all the things, sweep the eaves, keep it out of the attic, because you're exactly right, Silvernail, that when you go in that front door, because what happens when you go in the front door? You give the fire a bunch of air, you create the bidirectional flow path, the fire grows, you're actually causing the fire to blow out the window more with the ventilation from the front door, which there increases the fire that's coming out the window and up into the attic. And that's the last thing. Anybody who has any bit of experience knows that a fire in the attic is a losing situation for us. We want to keep it out of the attic. That sucks, right? It's like, now we're in a whole nother scenario where we're in this overhaul mode where we're having to hook the ceiling and it continues to grow in the attic. And even as we hook the ceiling, we're giving it more air, and an attic fire is terrible, right? That's a losing scenario for us. It's causing more property damage. Things are getting worse. So try to keep it out of the attic. If you can keep it in, yeah, that's exactly it. Yeah, it turns into that. So yeah, if you can keep it in its container, just in that one room fire, that's what we want, right? We want to keep it there. And that's a win for everybody, because even that one room fire is killing the victim that's laying in the bedroom next door, and that's what our focus has to be. Our focus has to be on the victims and being able to get into there. So putting water on the fire as quickly as possible and getting in and searching as quickly as possible.
And the fact is, even in the most well-kept homes, we don't really know what we're going to run into till we get inside. We can think it's only going to take us 30 seconds to get to that room, but it could take us 5 minutes. And that fire is going to grow unchecked, especially when you combine that with it's a multifamily building. You auto exposes in the units above, balconies above, things of that nature. But I think we know content problems are a significant issue in a lot of homes today. And so the likelihood of us getting in there as quickly as we might think we are is probably not accurate.
No, yeah, that's a huge issue. I mean, we had this scenario where we're like, when do we call a fire a hoarding fire or not a hoarding fire? And now it's like just about every fire is a hoarding fire. It's because there's just so much stuff in these places, right? And people just accumulate just tons of crap. And then that's a kind of misnomer on ventilation. Is a lot of people are like, oh, well, a hoarding fire is going to be much worse. And they're actually, the more stuff you stuff in there, the fire has a harder time getting to, the air has a harder time getting to the fire, because of all the little trails that are built up and everything that's in there. And so like we tested that at UL. It was like, what happens if you just stuff the thing full of couches? Well, the fire's got to have air down low to travel inside to make it worse. So yes, we are adding more fuel, but it just makes it a darker, sootier, nastier fire. It doesn't make it like that it's going to flash over any faster. So it's kind of an interesting ventilation piece to think about, is a lot of people think hoarding fires are worse, and they're not. They're more difficult to move hose lines. They're more difficult to search in. They're more difficult to overhaul in. And it just takes a long time to get to the scene of the fire.
I did like what you said about all the verbiage, transitional. Let's forget about that. Let's get to a point where this is part of the offensive interior attack. I think that this is going to be ingrained into. It's just another tool in the offensive interior attack to me. Let's stop getting. Is it offensive? Is it defensive? Is it transitional? I think that's important. I mean, there is a difference between offensive and defensive for sure. And yeah, there is a transitional point where I might go in, I might try to make a stab and get back out because I know it's a loser. That's transitional as well. But the cases that we're talking about are extremely they're just simply offensive.
Right. We like to say it's always offensive. If there's searchable space, it's always offensive. Right. And so
that's a great point.
Defensive, when we're having to back out because we were offensive. The building started to fall on us. There's a firefighter safety concern. We're needing to reposition lines because we're not in a winning situation anymore. And we're in a situation that is the building's collapsing on top of us, and that's a defensive fire. So, but we were offensive in the beginning, right? So it's that period of transitioning to the defensive mode.
Okay, real quick, where is culture today in the fire service? Are we embracing this? I know it's greater than it was in 2013, but where are we and where do we have to go?
I say yes. I think we're winning. I think that where we're not winning, we're not going to win at this point. I think that there's enough research and there's enough instruction across the country where we're now educating recruit firefighters and new firefighters coming in properly with the proper information. The ones that we're not winning on are the members that have been here a long time that we're not going to change their heart and souls. So we have to just kind of ride it out and wait for some more retirements, and through attrition, we'll get there. But I think we've come a long way in a very short amount of time, and I think the fire services and our communities are much safer and better for it today.
Yeah, sometimes we get better one retirement at a time, right? But no, so in all fairness, I think on that with the culture, I think that there's a lot of sensationalism on social media, and so a lot of our younger members are watching the TikTok and the Instagram reels and all of that pieces, and they have to remember that that's a very small time frame on an actual fire. So when you see sensationalism happening through social media, it looks really cool. It's really bitching, and that might not be real life. And so sometimes I think people get caught up in that. So, and we see that definitely like in the teaching circles, the guys that have really cool social media with a lot of sensationalistic stuff seem to be the most popular speakers, where they may not be in line with what the professional service is talking about, right? So
drama sells, buddy. Drama sells, yeah. And that's why a good novel has antagonism.
Yep. Yeah. No. Eric Roden told me that a long time ago when we started the Stop Believing Start Knowing thing. He's like, there's a reason that Jerry Springer is still on TV, right? and he was right. It was like, yeah, because we were kind of poking the bear, right? Poking all the traditionalists, and so there's a reason that we have 220,000 followers on our Facebook page. So, yeah.
That's a great thing, though. I mean, getting that word out there is phenomenal. And it's been a hard struggle. I've watched you guys from the beginning. I watched you guys. I watched Eddie Buchanan. And, it takes – that's true leadership, when you stand up to that. So kudos to both of you. And,
I got a lot of wrinkles and some gray hair over it. But, yeah, we're there. So.
All right. Jay, you got anything to add about culture?
At least you're keeping your hair. No, what you guys are doing is fantastic, and the article was great, and it's been very interesting to watch the progression of the studies become more accepted. It's a slow walk for sure, but the work that the two of you have done have certainly helped that progression. So we're grateful for that.
Yeah, and I think I got to give credit to the FSRI boot camps. PJ, I'm just a huge fan of the boot camps, and that is such a huge win to be able to get out and really do fire dynamic stuff with people. And it's a train the trainer program, and more to come on that. I'm actually going to UL next week to go do some filming because they're building an entire curriculum piece that people will be able to take an online boot camp and be able to take and put it to their departments. And the stuff that FSRI is doing is amazing. The content keeps getting better. If you're not online and you're not on the FSRI Fire Safety Academy yet, it's free. I mean, every fire chief out there should be using that as their LMS system because it's free. Why wouldn't you? And getting your people trained up on this stuff. So huge content. And I think that's where really the boot camp curriculum kind of took a lot of this out. And we saw last week the state of Utah, their state academy, they finally did their own boot camp without anybody from UL being there. And which was awesome to see, right? They build their own water mapping props. They built all of this stuff that we've been wanting people to do. Like, hey, here it all is. Here, please take it, do it. It's been, I love to see that stuff happening. So,
all right. Before we switch gears, I want to say it one more time. This is from July 24 from Fire Engineering, and the article is entitled Modern Firefighting Tactics in Residential Structures, Ventilation, Coordination, and Control. I screwed it up earlier because I had my screen down, and I completely apologize. I hope no offense was taken by our two colleagues and friends here today.
We've had much worse said about us. It's okay.
There is fallibility, pal. What we do. So switching gears real quick, talking about culture change. PJ did have another article put out, and he asked that we talk about it, and I wholeheartedly agreed to do that. So here it is, and there he is. Look at PJ.
What a horrendous photo.
Stop wearing your gear. Call for a change. PJ, as a fire chief, why are you telling my people not to wear their fire gear after I've tried to get them to wear their fire gear to automatic alarms and everything else?
You know, in the spirit of time, we'll just kind of hit this quick because, and I appreciate you giving me a few minutes to talk about this. You know, I got much less hate mail for this and phone calls of people disagreeing than I actually anticipated. You know, here's what it comes down to is we know the risks associated with cancer. You know, some of us have a little more personal attachment to it than others, but we have all been impacted by cancer one way or another, either us directly or through family, friends, or coworkers. And we know in the fire service, our percentages are higher than the average citizen. So we need to look at ways to reduce our risk. We're not going to eliminate it. It's the business that we're in. We're not going to eliminate the risk of cancer. And the cancer puzzle has many, many pieces to it. And as a leader in the fire service and fire chief in the fire service, in my opinion, you need to start looking at ways that you can reduce the risk for your membership. And that's many ways. You know, gross decon, exhaust systems, no tobacco policies, physical fitness programs, physicals, you know, and that list goes on and on and on. And we're very comfortable talking about that stuff. But there's one piece that, in my opinion, we really haven't started to dive into too much is our personal protective equipment. Now, we all know that our structural firefighting gear has PFAS, right? We have no other option at this point. There is no structural firefighting gear in the market that does not have PFAS in it. Well, I was raised, I know Sean was brought up and everybody on this call, when you leave the firehouse, you wear your personal protective equipment. You wear at least your night hitch, you go for a run. If you go to an EMS call, you wear your personal protective equipment, which is structural firefighting gear. You go to a public service call, you wear structural firefighting gear, right? That's what we were given. That's what we wear, and that's the job we have. Well, when you start looking at it, do we really need to wear structural firefighting gear or structural firefighting personal protective equipment for everything that we do, right? It's structural firefighting gear for a reason. Do we need to wear that on EMS calls? Do we need to wear that on public service calls? Do we need to wear that for some training? Do we need to wear that gear out when we're going to the grocery store to get the meal? When we're increasing our risk by the more that we actually wear that. So if we can look at ways to reduce the time that we're actually in that gear, we're reducing our exposure to PFAS. So let's look at what I'm doing here at the Connecticut Fire Academy. All of my instructors prior to me starting as a director were issued structural firefighting gear. They wear that structural firefighting gear out on the training grounds, 8 hours a day, many days a week, and very few of those days are doing live fire training, right? We do less than, we do about between 20 and 30 days of live fire training a year, and that's not my 200 instructors, small group of instructors, but we're all giving them structural firefighting gear. So you look at it from a financial perspective, we're spending, $3,000 or more on a set of structural firefighting gear that 90% of what they do, they don't need to wear it for. They need something to protect them from cuts and abrasions. They need protection when they're doing extrication. They need protection when they're stretching hose lines. They need head protection. They need boots. They need gloves. So let's look at something else. Let's look at PPE that's focused for the task that they're doing. So that's where now at the Connecticut Fire Academy, we do not issue structural firefighting gear. We issue dual purpose or single layer gear, which is PFAS free. It offers them all the protection that they need for all of the training that they do here, except for live fire. We have about 80 sets of live fire personal protective equipment that we issue on a daily basis to the instructors doing live fire. At the end of the day, we collect that gear, we decon it, we wash it, we launder it, we reassemble it and put it back on the rack. So my live fire instructors are never wearing dirty gear. And everything that they wear every other day in the fire ground is dual purpose, single layer, call it what you want. It's clean. It's reducing their risk to PFAS. It's reducing their risk to carcinogens because what they're wearing every day is not getting the carcinogens from the fire ground. So now can we apply that to our fire departments? Yeah, Absolutely. That's a significant cultural change. So I wanted to bring this up, throw it out there, and start the conversation, because everywhere's a little bit different. And I know that there's many departments that are not getting 10 years out of their structural firefighting gear because their members are wearing it on every call. And then departments don't have the financial funds to give them 2 sets of structural firefighting gear. So could you buy 1 set of structural gear and 1 set of dual purpose gear? They wear the dual purpose gear for 70-80% of their calls and things that they do. You're going to extend the life expectancy of that structural gear. And in the big picture, it's a good financial decision, but you're also reducing the risk for your membership.
Single layer gear has been one of the biggest wins in morale here in my department in the last 2 years. We got single layer gear and people love it. Love it. So it's hot in the summer in Atlanta. We don't want to wear our turnout gear on the interstate.
Sean, and that's a piece that I missed in the article. I didn't talk about the cardiovascular impact of structural firefighting gear and the heat retention of structural firefighting gear when we wear it for all those non-structure related calls. So there's a lot of other impacts as well that I could have hit, but trying to keep it short of an article to drive a message is where I went.
I'll just help out your guys' listeners. So if you're going to take this and try to research it, look up line of duty death firefighter Stacy Boulware from Cobb County, Georgia. Stacy was unfortunately wearing turnout gear and had a cardiac episode, and that was believed to be a cause was internal body core temperature. Yep.
Well, thank you both.
Hey, one more thing, fellas. Sorry, Jim. If somebody that watches this wants to learn about how you implemented that or the type of equipment you're talking about, how can they get a hold of you to be able to ask those questions?
Feel free to put our email address up, stuff like that. We're happy to share that. But I'm ffseangray@gmail.com.
Yep, and paul.norwood@ct.gov. Quickest way to reach me.
All right, great. Thanks for sharing that.
All right, we've come to that point for final comments. Go around the horn. You guys have any final comments before we tune out of here?
I'll go first. Just thank you. Thanks for the opportunity to talk about both articles. But more importantly, thank you to both for what you both do in the fire service. I know you gave Sean and I a lot of accolades, but we're just 2 voices that are very similar to both of your voices. You guys have, we've both looked up to you. In mentorship and friendship over the many years since we became friends through FDIC. We appreciate what you do for the fire service, what you've done for us as well. So thank you, and thanks for the opportunity today. It's greatly appreciated.
Thank you, buddy.
Yeah, I was going to say something similar to what PJ said. Thank you guys so much for your mentorship, and what a sign that hangs on the wall here in Cobb County is we stand on the shoulders of those that came before us, and you guys were here before me, and I appreciate your guys' mentorship and kind of showing me the way through the fire engineering world and all the pieces that are part of that.
Thanks for the kind words. It's been great. Proud to be associated with you too on a professional level and on a personal level. Everything you guys have done.
Thank you, guys.
Definitely. Jason, put our final plugs in, will you?
Final plugs. Well, for those of you that submitted to FDIC, you should be getting letters or have gotten letters. So congratulations to all of you that received confirmation that you'll be presenting at FDIC 2025. And I know they're not done sending those out yet. Those of you that didn't maybe get the response you were hoping for this year, don't give up. Think about participating in throwing an article out there, whether it's just a nugget on the digital side or attempt to get on the print side. And we're always reminded as authors and contributors that the print version isn't the be all of fire engineering. They get a lot more views on the digital side. So don't be disappointed if that's where your content goes. Be proud of that. And keep plugging away and keep making your contributions to the fire service. And I know that I can probably speak for the 4 of us here. If you ever have questions about what you might want to do different or anything like that, please reach out to us. But congratulations to all of those. Look forward to seeing everybody in 2025. And get the magazine, both the July and the August. I just got my August issue today, actually. So Make sure you're reading the magazine and the online content and getting all the news. Go to UL, like Sean and PJ both mentioned, and follow both of them.
All right. This concludes another episode of Fire Engineering's Tactical Impact. On behalf of the four of us, I wanted to thank you all for tuning in, and as always, stay safe.
Take care, everybody.
Take care.
Breathing in diesel exhaust fumes is like walking into a fire without a mask. Over time, those toxins lead to cancer. Protect yourself with MagnaGrip, the easiest, most reliable exhaust removal system that features a true 100% seal to eliminate diesel exhaust fumes. To get free grant assistance, visit magnagrip.com